Welcome to the deep dive. So, we're jumping into the sources you sent us today and exploring a connection that might seem a bit surprising at first.
That's right. Yeah. We're looking at how some pretty fundamental ideas from math calculus, specifically differentiation and integration, how they actually connect directly to, well, forest resource technology.
And even digging a bit deeper there, how these, math tools become really essential for understanding something specific, like soil nutrient depletion rates
Right.
in forests.
Yeah, exactly. So our mission really in this deep dive is to sort of unpack how that link works
Yeah.
and maybe highlight why it matters, especially if you're, wrestling with differentiation and integration yourself right now.
Okay, so let's get into it. What are these sources telling us about this relationship, calculus ideas, and, well, what's happening with soil nutrients?
But what's really fascinating, I think, is how these abstract concepts, the stuff you see in class, they map so directly onto, real world things happening out there. Differentiation, which is all about rates of change, right?
Right. Speed, basically.
Exactly. It gives forest scientists this power to measure precisely how fast nutrients are being lost or, changing in the soil over time.
Okay, so it's not just knowing, okay, nutrients are going down, but getting a real handle on the speed of it, like right now.
Precisely. Yeah. For instance, the sources talk about using differentiation to model the, say, rate of nitrogen depletion in certain forests after maybe logging or a big rainfall event. They'd collect soil data over time, maybe fit a function to it, and then the derivative of that function. That tells them the instantaneous rate, how much nitrogen is vanishing per year, maybe even per month.
Wow, okay. That level of detail seems like it would make a huge difference for planning.
Oh, absolutely.
So what about integration then? How does that fit in?
Well, if differentiation gives you the rate, the speed, integration
Right.
tells you about the total accumulation or the total change over a period.
Okay.
So thinking about soil nutrients, integration lets researchers figure out the total amount of something, phosphorus, potassium, whatever, that's been lost from a specific patch of forest over, say, a whole growing season,
I see.
or even, over the entire life of a stand of trees.
Okay, right. So differentiation is the snapshot, the speed at a moment, and integration gives you that bigger picture, the total impact over time or area. Makes sense.
Exactly. They really complement each other, and they give forest managers these quantitative tools, ways to actually measure and understand how dynamic soil health is. I mean, this ability to measure, model, predict these changes,
Yeah.
it's fundamental if you want sustainable forestry.
Right. You can't really manage what you can't measure effectively.
Precisely.
So here's where it really connects back, I think, especially for you if you're maybe deep in calculus homework right now. This stuff, it isn't just abstract theory for an exam. These are the actual tools people are using, out in the field, in labs, to understand the health, the future of our forests.
Absolutely.
Yeah.
Yeah, seeing that finding a derivative or calculating an integral, seeing that it's directly applied to analyzing something so, well, tangible and vital like soil nutrients.
Yeah.
Hopefully that kind of shifts your perspective maybe.
Yeah, on why these concepts matter beyond just, the textbook or the classroom.
Right.
It shows that maybe the hard work you're putting in to get these techniques down, it actually has real significant applications in fields you might not even expect, like environmental science, resource management.
Yeah, definitely.
So, okay, pulling back a bit from our deep dive into these sources, what's the main takeaway here?
Well, I think the core finding is pretty clear.
Hmm.
Differentiation and integration. They're definitely not just stuck in academia.
Right. They're practical, really powerful tools, and they're actively used in fields like forest resource tech to figure out complex natural processes, giving us these crucial insights into things like, the rate and the total amount of soil nutrient loss.
Exactly. And that just reinforces how relevant they are in the real world, especially for anyone studying them right now. It shows that math is, well, it's a language, isn't it?
A language for understanding the world.
Yeah, including the health of our forests.
So maybe that leaves us with a final thought for you to mull over.
Yeah.
Just consider how many other places, maybe unexpected places, are these mathematical tools, perhaps the very ones you're working on now? How often are they quietly working behind the scenes, helping us understand and, interact with the really complex natural systems all around us, the ones that sustain us?